All right, it's that time. So let me share a couple things with you so you know what's going on. Uh, we're remote today. I have a feeling we'll probably be remote tomorrow because we should get some snow tomorrow. There's also a possibility of some snow for Thursday and Friday. And we're going to actually talk about the connections between like oceanography and meteorology and stuff. But all of this snow we've gotten so far this year and the snow that we'll get this week all comes from the Gulf of Mexico. It's all Atlantic Ocean precipitation, and the jet stream has dipped way far into the southern part of the central United States, down into Texas. They had temperatures below zero down in Dallas and Houston, and Galveston, which is peculiar for southern Texas. Anyway, so in the chapter 2 folder, let's see, somebody else in the chapter 2 folder, uh, you should have a copy of the study guide, and we're kind of working through the ideas in there. We went through stuff about the chapter 2 basics, and the continental drift lab. You should have completed that by Friday. The problems and the assignments in this class are not optional. There's a bunch of you that didn't do the continental drift lab. You got to do the stuff, just the same as there's an activity for today I just posted that you should complete by tomorrow. It says the tectonic plate activity, so you got to make sure you get that stuff done. Um, this thing here that says plate boundary features, that's what I want to kind of go over today. And along with the plate boundary features, that's related to the tectonic plate activity. So in the plan for the week, for this week, I only have today and tomorrow because I kind of got to wait to see how things are going to go for the week. There's a YouTube video that I posted here. So it says Introduction to Tectonic Plates and Plate Boundaries. This video is a very good video to watch. And I'll tell you what, you can find it there, but I'm going to put a link in the chat. And whenever we're done, I'm not going to spend too much time talking with you this period because you'll have time to work on some stuff. But I just put a link to a video in the chat. Showing videos through Zoom is not so good because the video itself's all choppy. So you want to watch that. It's pretty brief, but it shows an animation of the kind of things that are like still images that I'll show you today. So I want to tell you about different kinds of plate boundaries, give you some examples, and then there's time to work on the tectonic plate activity. You can click on the link right here. It'll take you directly to it, or you can find it on the right hand side in the class. But basically, in the tectonic plate activity, the deal is you now know that there are these plates of crust on the Earth which can move around. And in the past, the plates were located in different locations. I describe here in the tectonic plate activity the three different types of boundaries that exist between plates. There are convergent boundaries, divergent boundaries, and transform boundaries. And there's a map that I provided here that shows all of the different plates on the Earth. And it looks a little bit blurry through Zoom, but when you open it, it should look just fine, especially if you zoom in a little bit. So there are all these different plates around the Earth, and they can all move relative to each other. The one plate, which is mostly underwater, is the Pacific plate. And that's the largest of the oceans. And then other plates are mostly continental plates, like the Eurasian plate, which is like Europe and Asia, the North American plate. Those plates are mostly continental plates. So what that means is they're plates that are mostly land that's exposed above the ocean. Most of Asia, this Asian plate, is above the ocean. But the Pacific plate, all this white area, the Pacific plate is almost entirely ocean floor, with the few exceptions of the small islands that are located around the Pacific Ocean. But all these lines that are shown all around the map, and the arrows indicate boundaries between plates. So, for instance, the Pacific plate is this large plate, which represents the Pacific Ocean, and then the North American plate, and we're like right here, there's a boundary that exists between the Pacific and North American plate, and that plate boundary runs along like this. Similarly, the island of or the islands that make up Japan, they're on the Eurasian plate and they're separated from the Pacific plate. And this line here tells you about the motion on those plates. So in the activity, I ask you to like locate plate boundaries between certain places on the Earth. What's the name of the feature at the plate boundary? And then what's the relative motion? And there are some different kinds of plates, the plates between Antarctica and Australia, the Nazca plate and South American plate, the Caribbean plate by Florida. And besides that, there are these things called hotspots. So in a video from last week, I mentioned and showed about the Hawaii hotspot. And those hotspots are places that are within a plate where magma can come up through the center of the plate. So really like the Pacific plate is a big flat piece of rock, and underneath it is magma. But this is a place where magma can come up through the surface and it forms the Hawaiian island chain. And there are other famous examples of that. So off the west coast of Africa, there's a group of islands called the Canary Islands. And the Canary Islands are also a location of a hotspot. The Easter Island hotspot, the Easter Island, that's famous for like the big moai, like the big people that are made of stone. Uh, that's on this hotspot, which is actually pretty close to a plate boundary. There's also the Tasman hotspot off the southwest coast of Australia. So these different and also in the plate, the hotspots can also be continental. So famously, up in mostly in Wyoming, the Yellowstone National Park, which is an enormous national park, it's famous for having hot springs and geysers. That's a place where magma comes very close to the surface of the earth, and the geothermal features which are present in Yellowstone National Park, as well as the geothermal features in Iceland, are as a result of magma being very close to the surface, causing heating of water, causing geysers and hot springs, features like that on the Earth. So here's the way to read this. On this map, there are places like up here where the Aleutian Trench is, that's the name of the feature. There are arrows that are pointing toward each other. So what that indicates is like the Pacific plate is moving to the north, and at the same time, this North American plate is moving to the south. This is a place where those plates collide, where they run into each other. Similarly, down here in the South Pacific, between, well, the Southern Pacific Ocean and Antarctica, there's a place here where there are arrows that move apart from each other. This is a place where the Antarctic plate is moving to the southeast and the Pacific plate is moving to the northwest. So if the arrows are moving away from each other, those plates are currently moving away from each other. And then you'll find other places where the plates slip side to side. So for instance, down here, there's a place where there's an arrow that points toward the southeast and an arrow that points toward the northwest. And this is a place where this part of the plate is heading in that direction, and this part of the plate is heading in that direction. So those three different ways that plates move relative to each other are either moving toward each other, like up here at the Aleutian Trench, away from each other, like here at the East Pacific Ridge, or sliding alongside each other, which is actually common all around um, the Scotia plate down here. So let me go over those different ideas with you. In the folder, in the chapter 2 folder, you'll find a document that says plate boundary features, and that plate boundary features document is a PowerPoint slide deck. The video that's mentioned in here is the one that I just put in chat. So the three different kinds of plates include convergent plates, divergent plates, and then these transform boundaries. What it means to be convergent or to converge means to come together or to become one. What it means to diverge is to move apart or to separate. And then the transform boundaries are places where they slip side to side. So these are illustrations from your textbook describing the basic things that happen. The diagram on the left-hand side has a general overview of all the different sorts of features that can happen on the ocean floor as a result of the motion of magma. So the demonstration that I did in class where, I had the hot water and the cold water in the tubes and they ended up mixing is as a result of magma, which is deep in the ocean or deep in the earth. It rises up towards the Earth's surface. And in this illustration here, you've got some magma which rises up and kind of falls to the right, and some magma which rises up and falls toward the left, because you have these circulation patterns of magma within the Earth. In the case of the magma rising up and moving to the right, as this magma is moving to the right, it drags this plate toward the right in that diagram. At the same time, this magma, which rises up and moves to the left, drags this plate to the left. So in a way, it's like a conveyor belt. As the molten rock moves toward the left in this diagram, it drags this plate toward the left. And then it turns out that here, where these two plates move apart, this plate moving to the left and this plate moving to the right in that diagram, you end up having some magma pop up through the places where the plates met. And that's a place in the ocean floor where you get these mid-ocean ridges at a spreading center. So the feature is a spreading center, and at that spreading center, you actually get a ridge, a very long mountain chain. And the longest mountain chain on the Earth is actually under the ocean, under the Atlantic Ocean, where the largest mid-ocean ridge is. So this kind of feature here is a divergent boundary. It's a place where there's a plate right here and a plate right here, which move apart from each other. This plate going to the left, this plate going to the right, and the place where they were joined together, those parts move apart divergently. So in the case of magma rising up and separating, some going to the right, some going to the left, it drags the plate right and left. That's a divergent plate. But then there have to be places where if plate moves apart, you've got to have other places where plates move together. So in this illustration here too, you've got a bunch of continental plate. This is a place where there's like land, maybe, maybe North America, maybe Asia, whatever. And this plate is either moving or stationary, it doesn't matter. But as the plate here in the ocean, which we describe moving to the right, it runs into another plate. And a couple of different things can happen. They can run into each other and build up mountains, which is what's going on with the Himalaya mountains and the Rocky Mountains. But when it comes to the ocean, what we most often find is that these plates end up subducting each other, which means going underneath each other. So here, if this plate is moving to the right and this plate's moving to the left, it turns out that instead of building a mountain up, what typically happens, what we see all around the Earth, is that this plate will underride another plate. And this rock here, which was the ocean floor, ends up going deeper into the Earth and becoming molten. So in this illustration up here, for a convergent plate, the reason why the plates move relative to each other and come together is because somewhere else plates had to move apart. And I guess it's kind of counterintuitive or ironic, but the places where we get the deepest ocean trenches, the deepest places in the ocean, happen where those plates come together. Because like in this illustration here, when this plate drops down, it ends up dragging ocean floor down and you get a trench. You get a depression in the ocean floor and very, very deep water. So the deepest point in the world's oceans is in the Mariana Trench, just off of Guam. So one of the deepest places in the ocean is actually just offshore, much like in this diagram here. You've got like land, and then not far offshore, you end up with these trenches that exist. So besides plates coming or moving apart as a divergent boundary and plates coming together as a convergent boundary, because the Earth is a sphere and these plates are moving relative to each other, you can't just have coming together and moving apart. There are also boundaries where the plates slide side to side relative to each other. And when these plates slide side to side, we just call that a transform boundary. And sometimes when these plates slide, they can move up and down as well. But most of the time we notice this is like a rip or a tear. There are places both on land and in the ocean where we see those transform boundaries exist. In the United States, the most famous transform boundary is the San Andreas Fault, which is in California. It's the area with the greatest amount of earthquake activity in the continental United States. And it's a transform boundary. And I'll show you some of the really cool examples of what transform boundaries can do to land and with land, like within cities. Okay, so that's a brief overview. This diagram shows a little bit of everything. So here's some particular things about the different places. So in this map, which is also another map, but it's not as detailed as the one in the assignment, you can see each of those features. So maybe we'll pick up here between Canada and like the British Isles. There's this plate boundary where North America is moving to the west and Europe is moving to the east. This is a divergent boundary where the plates move away from each other, and we expect, and what we find is a mid-ocean ridge that runs all the way down through the Atlantic Ocean. So all the way along here, you've got plates moving apart. That's a divergent boundary. We have other places like up here in the Aleutian Island chain. The Aleutian Islands are the islands off of Alaska. So this is Alaska up here. The Aleutian Islands run from Alaska through the North Pacific Ocean over to the Kamchatka Peninsula in Siberia in Russia. And this is a place where the plates move together. So you've got this plate moving toward the south and this plate moving toward the north. And as a result, you get a convergent boundary. And then this is the place where the San Andreas Fault in California is. So, like Baja, Mexico is, and southwestern California, like around Los Angeles, is moving toward the northeast. And at the same time, Northern California is moving toward, or I'm sorry, northwest. Northern California is moving toward the southeast. So there's a myth that like California is going to fall into the ocean or something like that. That's not it at all. But it turns out that places like San Diego are heading toward the northwest, and places like San Francisco are heading toward the southeast. So places in California will eventually meet up whenever they're currently separated by, in some places, hundreds of miles. So here's some specific things that happen at convergent plate boundaries. We have these different terminology. The where the two plates meet to converge, there's a plate that's on top that's called the overriding plate, and then the plate which goes underneath it is called the subducting plate. And the reason why this convergent plate boundary exists is because you get motion of magma, which rises up and moves, like in this diagram, toward the right and falls back down. And that drags this ocean floor toward the right. And you get a trench as a common feature which exists at that plate boundary. Some places where we see that, if you go to Google Earth, like I showed you, and you start zooming in when you're in the satellite view, you can see these features on the ocean floor. So this is South America, and this is Chile, and the boundary exists here right where this trench is. It's called the Peru-Chile Trench. And the deal is that this South American plate includes all the continent and then some of the ocean up to about here. This plate, called the Nazca Plate, is heading to the right, while the South American plate is heading to the left in this picture, or toward the east and toward the west. This plate here on the ocean floor is going underneath the South American plate. So this is the subducting plate that's sliding underneath South America. And it turns out that as this plate slides underneath, it kind of like folds this land up and makes the Andes Mountains. So these mountains that are famous on the west coast of South America, including the very high Atacama Desert and places around Chile and Peru, this exists on land because as this plate folds underneath, it shoves this land up. But you also get this very, very, very deep trench, incredibly deep places in the ocean right along this boundary. So that's a famous place. And close to the United States, and all these boundaries, you get frequent earthquakes, and you can get tsunami, you get volcanic activity. So in the Caribbean, there's a plate called the Caribbean Plate, and the Caribbean islands, include a whole bunch of different independent countries. Puerto Rico is a territory of the United States, and then the island of Hispaniola, which has the Dominican Republic and Haiti, and then the British Virgin Islands, the U.S. Virgin Islands. They exist on the Caribbean Plate, but this North American plate is currently traveling toward the south, and that plate is subducting or underriding this Caribbean plate, which is higher. And as a result of this plate going down underneath, you get this incredibly deep trench just north of Puerto Rico. It's shown here as a very dark, uh, you know, dark purple or black color on the map. And that's how the Caribbean islands exist. Because as this plate underrides the Caribbean plate, it kind of folds the land up here. The deepest place in the world's ocean is along this trench called the Mariana Trench. And the deepest point is right here, a place called the Challenger Deep. So this plate, the Philippine plate, is the plate that's on top, and the Pacific plate is heading toward the west. And as this plate slides underneath this one here, it forms this deep ocean trench. And there are little islands all over the place here. The island of Guam, which is a U.S. territory as well, is very, very close to. So this is an island that sticks up above the ocean, is very close to the deepest trenches in the ocean. So it turns out there's a misconception that people think, well, if you want to go to the deepest place in the ocean, you should go out in the middle of the ocean. When in fact, out in the middle of oceans, oftentimes there is a mid-ocean ridge, which is actually a little bit shallower. The places where the deepest holes in the ocean exist, even here, like off the east coast of the Philippines. So these islands of the Philippines here, you see green for islands, and then just off the coast, it drops off to be very, very, very deep at this trench. So these deep ocean trenches are places that are usually oftentimes relatively close to land. So that's a good example of a convergent boundary. Divergent boundary, you get not only this motion of the magma where some magma moves to the east, some moves to the west, but some of it also rises up in order to form this mid-ocean ridge at the spreading center. And the most famous place in the world where this exists is in the middle of the Atlantic Ocean. So this is the North American plate. These are some provinces of Canada. And then up here is the British Isles, including, United Kingdom, Ireland. Here's Portugal and Spain. So you know this, that North America is moving to the west and Europe is moving to the east. And right in between those plates, as these plates separate, magma comes up to form a ridge, and that ridge is visible in Google Maps. So this is a mountain ridge which runs along the ocean floor. It's clearly visible. Another place where you see this is, so this is the west coast of South America again. You have the Nazca plate, which I already told you about, as a subducting plate. And then this is the Pacific plate, and you can see that like rip in the ocean floor as the Nazca plate moves to the east and the Pacific plate moves to the west. You get this mid-ocean ridge on the ocean floor. Places where transform boundaries exist, you can see it in Google Earth in a lot of different places. But to give you a sense as to the places I want to show you, so up here is Canada, some of the maritime provinces of Canada. This is the North Atlantic Ocean. And here's Ireland and UK again. You can clearly see the mid-Atlantic ridge running north and south. And then there's this line which runs east and west. And you might notice here that this line that runs up then sort of continues over here. This boundary is a transform boundary. So this area, if you zoom in, shows you this feature. So here's the mid-Atlantic ridge running north and south, and then it continues over here running north and south. This is a place on the ocean floor where there's a transform boundary. This part of the ocean floor is heading to the west, and this part of the ocean floor is heading to the east. So at some time in the past, this mountain ridge used to be continuous. It would travel up along here and then continue to the north. But because this part of the plate is now heading to the west and this part of the plate is heading to the east, this transform boundary exists where the land under the ocean slides side to side. So this is a more complicated idea, but you've got two things going on at once. South of the transform boundary, you've got a place where the North American plate is heading to the west and the Eurasian plate is heading to the east, and you get a mid-Atlantic ridge. Similarly, above that transform boundary, you've got a place here where there's another mid-Atlantic ridge. This plate is heading to the west, and this plate is heading to the east. So those are what the white arrows show. But at the same time, along this transform boundary, these red arrows indicate the overall direction of the plates relative to each other. So all of this is all heading to the right or to the east, and all of this is heading to the west. So you still get the formation of the mid-Atlantic ridge over here and over here, but there's a place where the ocean floor has been torn. You can see that pretty well, and it's pretty clear in Google Maps, but you can also see it in the, let's see, in the map that I provided in the tectonic plate activity. So these little lines, little scars like this, like this, like that, like this, these are all transform boundaries that exist along individual plates. So the place we were just looking at is actually right up here. So you can see that the mid-Atlantic ridge is discontinuous. Instead of it being a nice smooth line, a nice smooth curve, instead there's places where it gets broken up by those individual transform boundaries. But along the San Andreas Fault, it's a huge transform boundary that's very long. So, another thing that's very, very, very true is everywhere where this motion takes place, you get earthquakes, you get tsunami, you get volcanic activity. Here in Pennsylvania, we don't experience earthquakes and volcanoes like at all. And it's because we're out in the middle of a plate. It's a pretty boring place to be geologically. But if you want to be somewhere exciting geologically, the west coast of the United States has frequent earthquakes. If you go to, there was actually just a 7.1 magnitude earthquake just off the coast of Japan just yesterday, right along this plate boundary. They get frequent earthquakes and tsunami. The word tsunami actually is a word in Japanese because of the commonality of tsunami, which exists off the east coast of Japan. All right, so the tectonic plate activity I've described here about convergent boundaries, divergent boundaries, and transform boundaries, and what kind of motion you get. You can also use the plate boundary features PowerPoint to help you out, but it's a little bit of thing about geography, because here when I describe locate the plate boundary that exists between Antarctica and Australia, you should be able to identify on a map where Antarctica and where Australia are, find the name of what that feature is. And when I mean the name of the feature, like Aleutian Trench is a feature, or Juan de Fuca Plate is a feature, or Mid-Atlantic Ridge is a feature, or the Sandwich Plate is a feature. The names of the features are directly on the map itself. What's the motion toward or away? And what type of plate boundary exists? In other words, is it convergent, is it divergent, or is it a transform boundary? All right, so that's the plan. And from this point on in the course, as we look at images on Google Maps, understanding the geography, understanding the geology tells you everything about all the other things we're going to do in the course. So where the ocean is very deep, there's different forms of life. There's different levels of oxygen. There's different issues with pH and acidity than where the ocean is very shallow. The way that ocean currents move is oftentimes dependent upon ocean depth. So fundamental to everything in the rest of oceanography is understanding like all the different places in the ocean where the ocean is different in depth, where the different plates come together. The boring places in the ocean are where it's just a flat plane. We don't see much going on. The places in the ocean that are exciting to study are places where changes happen. And oftentimes, the greatest diversity of life exists where these plates come together. They're places that are good fishing spots. They're places near where people live. So much of our study of the ocean is highly dependent upon understanding the different kinds of plates and different plate boundaries and different plate features. All right. I think, let's see. Yeah, that's all I have for you today. I don't know what we're going to be doing tomorrow. And I mean, coming to school or not. If I put any money on it, we're probably going to be remote tomorrow as well because the possibility of snow. We had some freezing rain just a little bit earlier here where I live. I don't know if you had some freezing rain where you live. But so that's what I got for you today. You can work on the tectonic plate activity. You should be able to get that done by tomorrow. If you have questions or you're confused about something, you can stay and ask questions or put it in the chat or whatever. Otherwise, you can go. I got you all marked down for attendance.